First thing I want you to do this morning is I want you to again put your name in the upper left hand corner. Okay? Well, it's definitely what we would say in landscape. It's wider than it is tall. Okay? Good. Good. Okay. And you want to put a label at the top of this construction. So what we're going to create, or is we are creating parallel lines. I will tell you there's really more than one way to do this, but we're going to take an approach that uses one of our previous constructions. So if you look back at our third construction, or sorry, not our third, our second construction, this one right here, we created two perpendicular lines. How could I add on to this construction to create parallel lines? What could I do? Anyone want to offer up a suggestion, Casey?
From the point, I don't know what. Let's just do you can draw or the W down there.
Yeah, if we were at point W, what could we do?
Just draw a straight line.
All right, but we can't just draw a straight line. What would we construct?
Arches.
Okay, arches. So let's say, would I just draw a straight line like this through W, Casey?
No.
No, what would I have to do?
Make it parallel.
Okay, so if it was parallel to this line here, then it would be what to this line here?
Perpendicular.
It'd be perpendicular. So what we're going to do today is we are going to create a perpendicular line, and then we are going to create a second perpendicular line so that when we are done, we have two parallel lines. So we're going to use the techniques from our last lesson but we're going to do it, instead of doing it once, we're going to do it twice. Kennedy.
Is there like an extra page on this little package when we just use that one?
Yeah, that would be fine. Yep. Yep. I gave you guys lots of paper so that you had some paper to work with. All right, so that's what we're going to do this morning. So first thing I'm going to do is I'm going to go ahead and I'm going to draw my first line all the way up here. I'm going to put arrows on the ends. And I'm going to call this line M. Now the way that I'm going to do the perpendicular lines on this lesson is going to be just a hair different, but it still works. And I'll show you how that works. Now, I need to create two sets of perpendicular lines to end up with two parallel lines. So I am going to go ahead and, because I want to use as much space as possible, I'm going to go ahead and work right in the middle of my lines. I'm going to put a point there. I'm going to call that point A. It wouldn't have to be A. If you were partial to another letter, you could use that. Okay. I now need to construct my perpendicular line through point A to line M. So when I'm done, it's going to be like this, somewhere right in here, but I can't just draw it because that's not precise enough. I need to construct it. So I'm going to take my compass, I'm going to set it on my paper here, and I'm going to pick a distance that I think will work just fine for this. So I'm going to set my compass right around 3 centimeters. Okay? While that's not necessarily necessary, it helps to make sure that everything stays consistent. So I'm going to use this first hole here on my compass, which is set right around 3 centimeters. If it was 3.1, if it was 4, that's fine. We just don't want it to be all the way out at the end. And I'm going to slide my compass up so that the end of it is on point A right here. Clamp it. And I'm just going to make a little arc there. And I'm going to swing it around and make a little arc there and slide my compass off. And I'll give you just a moment to finish that. If they're big, yeah, if they're bigger than this, that's fine. Liam, even if it was an entire circle, that would still be fine too. Though, somewhat unnecessary, but fine. It wouldn't ruin the construction. Nope. Good question. All right. The next thing I have to do is, in order to put, if you remember, we had to create these arcs that intersect out at the top, and we did it at the bottom. To create those intersecting arcs, I have to make my compass just a bit longer than my original measurement here, so that it will meet out here and intersect. So what I'm going to do is I'm going to take my compass, I'm going to take my compass, and I'm not even going to really change it. I'm just going to use the outside hole now. Okay, so instead of using the inside, I'm going to use the outside. So where I have these intersections, I will call this, let's see, we'll call this pi, and we'll call this beta. Okay, pi and beta. You can call them yin and yang, though that's a more complicated symbol.
What's the symbol for?
Yin yang?
I'm just
Well,
gonna write
like
it.
that, but like, is there a tinier symbol to use?
No. She'd just have to draw half and then the other half, and they'd be separated, and it would be weird. But she could do it.
What's the beta symbol?
Beta is real simple. It's a very simple symbol. Beta is kind of like a curved beat, like that.
Is yin the white one?
What's beta stand for?
I'm not sure. Beta just stands for Greek letter B. Okay, here we go. I'm going to set my compass on the one side. I'm using the outside hole, and I'm going to go ahead and create an arc, like so. Without changing my compass then,
Hey, what did you do?
I put my compass over pi, and I created an arc using this outside hole. And then I'm going to do the exact same thing, but I'm going to use a different vertex point. So this time it's beta. So I'm just switching over to the other side real quick. I've got to clamp it down.
No, it takes me off.
I got it.
Like so.
How'd you get it connected? But mine are like 10 lines in a row.
How'd you get it connected?
My lines have to like.
How'd I get what connected? The two lines, like how they crisscrossed?
Yeah, watch how we did it.
Because mine didn't connect. Like,
I'm going to do it so that they are both almost right under A. So like if I were doing one over here and one over here, they'd never crisscross. So if you have to draw a big arc,
yeah,
So we
that's
have to
what
do it under A.
yeah, it has to be in this area of the paper. If you were trying to do it here or here, they would never cross. Okay, thank you. I'll take care of it. All right. Now, unlike our last construction where I did two of these, take a look. I did one here and here. Hey, guys. That is unnecessary. I really only need 2 points to create a line. So while I did enough for 3 in the last construction, it's adequate if I have just this point and this point to create a perpendicular line. I'm going to call this point N, and I am then going to connect A and N such that I now have a perpendicular line right here. Okay, there's a couple things we can do perspective-wise on this. And what I would encourage you to do, since it's easier to work with perpendicular lines when you're looking at them like as a plus sign, I'm going to go ahead and just turn my paper 90 degrees. Okay? You could turn it 90 that way, or you could turn it 90 this way. It doesn't matter. It just needs to be turned 90 degrees. And now really what I'm going to do, and you can try this on your own, okay? You can try this on your own. I am just going to construct another perpendicular line. So I'm going to walk through creating these 2 points and then an intersection point again. So if you wanted to try this on your own right now, by all means try it. Okay, but I'm going to walk through it slowly. If you want to work ahead, that's fine. And the reason that you're using pencils is if you make a mistake, you can erase it. So I'm going to start by creating a point on the line right here. I'm going to call that point X, or you could call it point Bob if you wanted. And I'm going to create or construct a perpendicular line using my compass through this point X so that when I'm done, I'll have a line like this. And when I'm done, this line and this line will be parallel. That's what I'm going for.
Like exactly parallel?
They will be exactly parallel, yes. So I'm going to take my compass. I'm going to start with it a little bit closer to the center because I'm working with a little bit less space. Really, your compass, sometimes you have to adjust it depending on how much space you have on the paper. If you didn't adjust it, it probably will still work. So I'm going to go ahead and set the compass over top of my new point, clamp it.
3.
You could do 2 or 3. I moved mine down to 2.
Are we using the inside hole?
I am using the inside hole, yep. You'll notice that it's a little bit closer to X this time than it was up here at pi and beta. That's fine. If it's a little bit closer, it could be super close. The only thing that matters here is that these arcs are the same distance from X. So they could be out really far. They could be a little bit closer. They could be a little bit closer or closer, etc. The only thing that matters is that they're the same distance.
Didn't you want us to make the line across? Like the one. Like that one.
The ones that are not these do need to cross. But these ones, like this one and this one, are going to sit on this line.
I mean, the line like that long line at the top. Didn't you want us to do that with X2?
I'm not quite sure what you're asking. Go ahead and ask your question again. I want to make sure that I can answer it.
Okay, so that line at the top.
Uh-huh. This one?
Yeah.
Okay.
Then you want us to do that same thing, but across X. Yeah.
Yep. That's what we're trying to do. Yes. That's a good question. All right. I'm just going to move my compass out a little bit. At this point in time, it doesn't really matter what I'm choosing so long as it's further out than this. I'm going to go ahead and I'm going to make this smiley face and this frowny face. They're really hard to see, but you can kind of see it. Smiley face and frowny face. Okay? And so, at smiley face, I'm going to put my compass over that point, clamp.
Does it not matter the distance or?
Does not matter the distance. It doesn't matter. You just do one and then do the other.
This one's gonna be
Notice where my arc is. Pause. Notice where it is. It's above X. Okay, I'm not making it over here. Okay, because if it was over here, it wouldn't work. It's got to be above X or below X.
So yeah, so could it be like underneath?
Sure. Could be there too. And then I flip over to the other face. This case, my case, frowny face. And I use the same hole. I use the outside one. You could use either one, and it will work for you, so long as you use the same one for both arcs. You'll know, by the way, if you've made a mistake, because your arcs won't look like they're the same. Okay? They'll look really off. Or when you're looking at it, you're like, yeah, if I line this up and it's crooked, yeah, that's probably not what I'm going for.
So if you were to like draw a straight line through both of them, would it be able to line up straight?
It should. It might be a hair off. These compasses are not
The most accurate.
super perfect, but
X is right there. I was doing my dots right here.
Why is your thing so
This is perpendicular. All right, hey. Shh. All right. What we've just created are two parallel lines. We've created this line and this line. I'm going to call this line line W. So line M and line W are parallel, whether they're like this or like this. If I wanted to create a perfect rectangle, I would just create another perpendicular line like over here, or if I wanted a square, I would just create it so that all four sides are the exact same distance, etc.
When you're making like models, you have to do this over and over again.
Yeah, but I mean, like for instance, what I'm doing here in a class period would only take me a couple of minutes if I were not having to explain it.
Are you saying we're slow?
No, what I'm saying is you're learning it. There's a difference.
So what's the next one that we're gonna do?
Well, I want to talk about this for a minute because, hey, Liam, and the others back there. Liam, what can you tell me about this angle here and this angle here? What would they be?
They are 90 degrees,
They're both 90 degrees.
and they're the same.
They're the same because they're both 90 degrees. But they're inside parallel lines on opposite sides of a transversal.
They're that one thing of
Alternate interior?
alternate interior.
They are alternate interior angles.
No problem.
On your diagram right now,
That was only tip of my
draw a slanted line that goes through both parallel lines. And label it transversal.
I'm behind, man.
That's fine.
And
That's why I'm recording this. Can anybody tell me,
Thank you.
watch me trace this, can anybody tell me what this figure is right here?
A trapezoid.
It's a trapezoid. Look at that.
Oh my gosh.
It's a trapezoid.
What's the measurement?
Look, I tried to do that cross thing.
Question. Okay. What can you tell me, David, about this angle here and this angle here?
They are also.
They are the same. They are that one thing.
Hang on. David. What are they, David?
They are alternate interior.
They are. What can you tell me, Landon Smith, about this angle? I'm going to do a double arc here. And this angle, which is also a double arc, here. They're on the same side of a transversal. On the... What are they? Do you remember?
Come on, man.
Starts with a C.
Complimentary.
No.
Corresponding. It's a C word.
Corresponding angle.
Yes.
Nice job, Landon Smith. Way to ace it like that.
Four angles.
They're corresponding angles.
Oh, man.
What can you tell me about this angle and this angle?
They're adjacent.
They are not adjacent, though that's a good guess, because they are opposite each other, not next to each other.
Vertical angle.
They're vertical angles.
Now how you cross this
What about, Drew, this angle and this angle? They are adjacent. And what else? This one and this one.
Supplementary.
They're supplementary because they add up to 180 degrees.
hey,
Don't tell me what to do.
This one and this one,
How's the bottom one?
this one and this one, when added together, are 180 degrees because it would go from here to here and it'd be one full semicircle. Okay.
Are you for real?
All right. Not too bad. Not too bad. We're going to call this, by the way, number 4.
I said it.
You did. You did.
That other one was number 4.
No, the other one.
was number 3, Mason. Mason, what do you be on?
Look.
No, because this was number 3. This one was 4, and then this should be 5.
3, 2, 1.
No, you guys are wrong.
Last but not least,
I'm making it 5.
You guys are wrong.
I'm not going to walk through it. I'll just, you number them what you want.
You guys need like an extra page.
Yeah.
Hey guys, 5, 4, 3, 2, 1. The last construction we are going to make is an equilateral triangle.
What's that number?
This is the one we just did.
He said
Something on the
that's 4.
screen.
He said the other one was the one we just did.
That's fine.
Whoa. Get that.
Okay.
I get it. You guys don't get it.
Shh.
You guys are going slow.
Hey, you guys.
Chill out.
Hey. This is my time to go through this. You need to pay attention. Thank you. I am going to call this number 5. And this is an equilateral triangle. This one's pretty easy. Okay? What we have to first understand is that equilateral triangles have the first thing we have to understand is that equilateral triangles have 3 equal sides. Okay? That's the whole point of an equilateral triangle. So, we are actually going to use, and let me go back to the very first construction we did where we create congruent segments. We're actually going to use this same construction today to go ahead and draw equilateral triangle. So I'm going to start, because that's how that one started, I'm going to start by creating a straight line. This is going to be the bottom of my triangle. Now, one of the things that we can also use in helping us to create this equilateral triangle is the fact that circles have the same radius no matter what. Okay? So what I'm going to do, and I want you to watch carefully, is I'm going to go ahead and place my compass, and I'm going to move my slider such that, I'm going to have to bring it back a little bit, such that when I put it over one side, and I'm not labeling it, okay, I put it over one side like so, clamp it, I'm going to line my compass up with the other end of the segment so that they're the same distance. But I'm going to leave it there and I'm going to draw a huge arc like so.
Wouldn't that be like a semicircle?
Well, yeah, technically it is almost a semicircle. This circle has the center point right here, and every line that goes out to that arc would be a radius, including the bottom line right here.
Oh, we're not supposed to draw all the way?
So somewhere out here is a point that is the same distance from this to this, and that's where our equilateral triangle point's going to be. So the next thing I'm going to do is I'm going to place my compass at the other end, and I'm going to line it up just a little bit, and I see that it is. I'm going to draw an arc to make sure that it goes through the point, and it does. And I'm going to bring it around, and I'm going to go all the way out like that.
So that's where your point is.
And that's where my point is. So where they intersect, I'm going to put a point. Now, how am I going to finish out this equilateral triangle?
You draw the line.
Yeah, I draw the lines. So I basically connect the only 3 points I have on this diagram. It is kind of frustrating when that happens, Drew.
Oh,
Boom.
So
This is
Illuminati.
awesome.
What is this dark magic?
What is this dark magic? Got it.
Man, evil.
This side of my triangle, this side of my triangle, and this side of my triangle are all exactly the same. What we've just constructed is an equilateral triangle. And because it is equilateral, this angle is 60 degrees. This angle is 60 degrees. And this angle is 60 degrees. And because all the angles and all the sides are the same, this is also considered a regular polygon, or we could say a regular triangle. How did I get what triangle?
In the middle, I was getting
Right here?
Yeah.
I drew one arc, okay, from this point. I drew another arc from that point, and where they intersected was the third point of my triangle.
So you just draw the lines.
Yep, so then I drew a line connecting these 2 points, and I drew a line connecting these 2 points.
That is so awesome.
And if I had just enough space, I could create a secondary equilateral triangle on the bottom. Actually, I want to see if I can do that, because if we did, we would be able to create a parallelogram.
Oh, snap.
Not sure that it's quite long enough to do this.
Oh, you got it. We're about to see.
Wow. It's like right there. So if I were to connect those points,
You would have like two of the exact same.
This is fun.
okay. Now, what's interesting, and this is the reason we did the equilateral triangle, is by creating 2 equilateral triangles, what did I create here and here?
A rhombus.
I created a rhombus, that is correct. This is a rhombus. All the sides are exactly the same. But what did we just create on our previous construction?
It's like a fun.
We created parallel lines. Aren't these also parallel? 'Cause it's a rhombus. Aren't these parallel? So I just created another set or 2 sets of parallel lines without using perpendicular lines.
Oh my god.
So I created parallel lines here, one way. I created parallel lines here and here. So if I were to extend these lines,
Oh, man.
if I were to extend that line that way, and I were to extend this line,
Dang, man, that's a clean triangle.
I have now got another set of parallel
I'm
lines.
proud of this triangle.
And lots of alternate interior angles, lots of corresponding angles, lots of supplementary and adjacent angles, and vertical angles.
Then we can create parallel lines.
Okay. All right, that ends these 2 constructions.